So we should know like what is the biomass, like how biomass can be defined, and what is the uh, different generation of biomass, and how the biomass can be converted to biofuel, and the biomass characterization part, introduction to this HTL process, and different HTL mechanisms, and HTL process methodologies, and different types of HTL reactors, and separation methods. What are the byproducts or biorefinery outputs of this HTL process, and the biocrude upgradation techniques, and what are the challenges and limitations from that. Right. So this are all my broad contents of my presentation, and start with the introduction. Like we all know about the transportation and industrialization, which leads to increase or the emission of this greenhouse gas emissions, which uses fossil fuels. So this is caused generally it increases the atmospheric CO2 levels. That increases the global warming potential, and that's why that we all look forward to take a shift towards alternative sources of energy like biofuels. So we biofuels means we all know about this biodiesel only in broad category, right? So in many of us from long time that we all are familiar with the term called biodiesel. Anyone, what do you mean by biodiesel? Can anyone answer me what is a biodiesel?
I say, sir, biodiesel is manufactured by transesterification of triglycerides with 3 moles of methyl alcohol.
Exactly, exactly. Very good, very good. So what is the raw material used for
Basically,
biodiesel
biomass
production?
origin, sir, we can say simply it is origin is
Triglycerides,
biomass.
vegetable oil or animal fat.
Animal fats. Very good. Exactly, exactly. Right. So most of
Hello.
the time, like from the last 2 decades, we can say that the research towards the alternative fuels or towards the biodiesel kind of fuels, and which are derivatives of vegetable oils, exclusively non-edible edible seeds, vegetable oils, and the demand for this alternative fuels like biodiesel is on the rise due to the growing concerns about the fossil fuel emissions. And here, for the HTL process, we introduce one more biomass as a feedstock. We call it as algae biomass. So this comes under the third generation biomass category, and this is going to be a promising biomass source due to this high photosynthetic efficiency and making them it's ideal for sustainable energy production and carbon capture. And this is the roadmap of the HTL process. So if I start with the selection of biomass, so there are different types of biomass. I will come to that in the next slides. So first generation, second generation, third generation, three broad category of biomass that you can classify it. And in that, maybe we start with the vegetable oils sources, which is going to yield biodiesel products, and alcohol kind of fuels, and then is algae biomass and plant biomass one. Right. So the first stage is that to select a proper appropriate biomass suitable for this HTL process, and then it need to be characterized like ultimate analysis, proximate analysis, and other chemical characterization that we need to do it to identify its potential towards suitability for this hydrothermal liquefaction process. Then move on to this HTL process and how the HTL process and what are the process variables have to be discussed. And then the uh, the yield, oil yield, we call it as biocrude. This is the yield that is obtained from this HTL process. The biocrude oil, whatever it is obtained from HTL process, that need to be characterized to know the physiochemical properties, and then we move on to these engine applications. Right. So this is the thing that we discuss about this generation of biomass. So there are three, or maybe you can add one more generation, fourth generation feedstocks. The first generation feedstocks are normally food crops, which are in the form of rice, corn, soybeans, which is being used for ethanol and biodiesel production at the older days. So, but there was some concerns about the food versus fuel. You all know about that, right? So that's why we take a shift towards non-edible kind of vegetable or non-edible kind of biomass resources for conversion process or biofuel production process. So there it comes the second generation feedstocks. So they are non-food biomass. So generally they are obtained from agricultural waste, forest residue, municipal solid waste, which contains higher energy density and lower environmental impact. And then the third generation feedstocks are aquatic plants like algae, seaweeds with high oil content, and it has rapid growth rates, and it requires less amount of land to cultivate it, and making them as a sustainable option for alternative energy production. The fourth generation feedstocks, it's been genetically modified biomass resources. Um, they genetically modify the microorganisms to cultivate this algae biomass, and which are again used to produce biofuels, but maybe it may yield higher amount of bio yield, and with some upgraded fuel properties, which has a promising potential for sustainable energy production. So the key benefits of the biomass is aim to address the concerns about the food security, land use, and environmental impact while improving the energy density and biofuel yields. So these are the broad category of biomass resources. You can see there the energy crops, then woody biomass, industrial waste, kitchen waste, forest residues, aquatic plants, algae biomass, and animal manure. Right. So all together that it is being shown in that in the image. And to start with the biomass characterization, so first we should know what is the elemental composition of biomass. So each biomass elements contain carbon, hydrogen, oxygen, nitrogen, and sulfur, with maximum amount of composition will be from carbon. So approximately 50% of carbon may be there in any biomass at dry weight basis. The carbon content, so higher carbon content levels in the biomass means that it has a higher heating value, and it has a very good thermal energy potential, and making it suitable for this renewable energy application. And hydrogen content is essential for biomass for its growth. It's a major content, and the sugarcane, corn, switchgrass, or algae are hydrogen-rich biomass resources, and that enhances. That's going to enhance the hydrothermal liquefaction process reaction rates and the heating value of the biocrude oil obtained from this HTL process. And the oxygen content, generally, oxygen, we know the of oxygen. Oxygen helps in combustion, cleaner combustion, but it affects the heating value of the biocrude. If excessive oxygen is there, that will mean that the calorific value of the fuel will reduce. So the target is that carbon to hydrogen ratio should be more for the oxygen content. But the by default, oxygen will be there in any biomass resources that is going to support the combustion phenomena to make it cleaner. So excess oxygen limits biocrude utility, while the sulfur and nitrogen negatively impact the biofuel properties and its performance. So overall, if you analyze the biomass composition, it reveals that the physicochemical properties and including its suitability for its various applications. Carbon and nitrogen are most essential for this biofuel production, and where the woody biomass contains 50 to 50% of carbon, and this herbaceous plant biomass contains 35 to 45% of carbon content. Move on to this proximate analysis of biomass. So first step, the second step, first is that the elemental analysis, that where we analyze the carbon, nitrogen, sulfur, oxygen, and next step is that to do the proximate analysis to find out the moisture content present in the biomass, ash content, volatile matter, and how much amount of fixed carbon is present in that. So this again important step in that biomass characterization. So the ash content should be as much as low. We should select the biomass where the ash content left out from the process should be as much as low. Then the moisture content, again, if the moisture content is going to affect the bio-oil conversion efficiency and its quality, so what generally people will do, and the researchers will do, before processing the biomass, it should be dried completely. So drying of biomass before processing, that will enhance the efficiency. But here for this particular STL process, there is no constraint of this moisture, because STL process can accommodate with a wet biomass also. Normally, other thermochemical conversion processes like pyrolysis or gasification, that requires dry biomass. There should not be any moisture content to get a maximum amount of yield. So we know about this pyrolysis is again a kind of thermochemical conversion process where you keep the substance in a reactor and you supply heat externally, and in the absence of air or oxygen environment, the biomass substance which is kept inside the pyrolysis reactor will undergo thermal decomposition, and that is going to yield a gaseous product. By condensing the biogaseous product, you can get a bio oil yield from that. So that's a pyrolysis process. Their moisture content should not be there. So it should be dried before using that in the pyrolysis condition. But for the HCl process, you can there is no constraint of this moisture content. And volatile matter, again, it's important that to select a biomass for biofuel production, generally higher amount of volatile matter is expected from a biomass, so that it will be easy to ignite and it will burn fastly and the combustion will be good, right? So for that purpose, a biomass, whatever we are going to choose it for our thermochemical conversion process, we should have high volatile matter content. And the fixed carbon content is generally determined after removing the volatile content and ash content. And so this again at the end product of the fixed carbon. If the fixed carbon content for the biomass may vary from 15 to 60 percentage. Another important parameter for any biomass, it should have a higher calorific value. So the calorific value, we classify that into higher calorific value and lower calorific value. But generally, whatever directly we get it from the biomass, by burning of biomass, it's higher heating value. So that represents the total thermal energy released during a complete combustion process. And there are different methods you can calculate this high rating value by proximate analysis, by analyzing the biomass composition from the moisture content, volatile matter, and fixed carbon, and even from this elemental composition CHNS analysis. And also conventionally, we all go with this bomb calorimetric measurement, where directly measuring the heat release from the biomass combustion using calorimeters. So these are the options to measure the uh, higher calorific value of a biomass material. Then move on to this biomass into biorefinery concepts. Like not only that, we aim only the liquid fuel alone. So you can aim at producing or converting some value-added products out of this biomass conversion. So in that, maybe you can go ahead. We maybe heard about this anaerobic digestion, fermentation, and transesterification process. They are all biological conversion methods, and in thermochemical conversion methods, we can elaborate with pyrolysis, gasification, and hydrothermal liquefaction process. So move on to this thermochemical conversion of biomass. The first category that I explained earlier, that's about the pyrolysis, where the reaction temperature is limited between 300 to 800 degrees Celsius, and this can be carried out at atmospheric pressure level. So the biomass will be kept in a pyrolysis reactor, and it will be heated at a temperature of 300 to 800 degree based on the thermogravimetric analysis part. And then it is going to leave the pyrolysis vapor. By condensing the pyrolysis vapor, you can collect this pyrolytic oil. We call it as bio oil, and also you can get a biochar out of this pyrolysis process. And the second method is gasification method. You heard about this fluidized bed gasification, or these fixed bed gasification, or many methods that you heard about that. And generally, this is again held at atmospheric pressure conditions, but the temperature is slightly higher than the pyrolysis one. So between 700 to 1200 degrees Celsius, the gasification process will happen. That is going to yield a gaseous product, not the liquid product. So generally the gasification is meant for producing syngas, which is a methane rich gas that you will get it from biomass resources. And the topic of our interest is on hydrothermal liquefaction process, where the reaction temperature can be maintained at lower levels. Say that compare the temperature of pyrolysis and gasification, the HTL process can be done at a temperature of less than 450 degrees Celsius, and but not at the atmospheric pressure conditions. Here we need to apply pressure also. So HTL process has input variables like pressure as well as temperature. So pressure should be between 15 megapascal to 25 megapascal, that is 150 bar to 250 bar pressure that you can apply to the reactor. So that is again going to yield a gaseous product, which is methane rich with carbon dioxide in remaining combustion. And if you get a liquid product out of that, you collect that as a biocrude and other value added products. And also, this is also going to leave a char. We call it as hydrochar, which can be used for producing activated carbons, and it can be used as a fertilizers. And this is about the introduction to this HTL process. So that hydrothermal liquefaction process is a chemical conversion process that is going to convert the wet biomass into a biocrude, which can be upgraded to produce renewable fuels, chemicals, and other valuable products. So this HTL process, again, the wet biomass is going to feed in a reactor, which is subject to high temperatures between 200 to 450 degrees Celsius and pressures up to 250 bar. And here, as it's told that there is no limitations of moisture content, so he can add water as a solvent to the biomass, and you can prepare the biomass slurry, right, by making mixture of this biomass and water, and this slurry has to be fed inside the reactor. I'll show the reaction conditions, right? So in this method, the complex biomass molecules are broken into simpler compounds such as hydrocarbons, oxygenated compounds, and water. So there are a variety of feedstocks that can be used in the HTL process. We can focus on exclusively on algae, municipal solid waste, and lignocellulose biomass. So it has a significant advantage that there is no need of the feedstock drying process, and which is going to reduce the energy input spent for the entire process. So it has a potential to play a significant role in meeting the growing demand for renewable fuels, and also it's going to reduce the greenhouse gas emissions, which is going to promote the sustainable development. So this is the reaction mechanism of this HTL process. So there are three major reactions that is going to take place during this HTL process. The first one is depolymerization, where the hydrolysis of biomass with water is going to happen, and or you can replace the water with any other solvents like ethanol, methanol, acetone, like that. The first step in the HTL process mechanism is depolymerization. You have to break down the molecules of biomass by mixing a solvent either with water or ethanol, methanol, acetone, or any other solvent. Second step is the degradation part, where this hydrolyzed monomers will undergo dehydration, where the water content has to be removed, and you can remove the other ammonia kind of things, the deamination, and decarboxylation. You can remove the excess carbon content from that. So finally, it will recombination process mechanism will happen, where this reactive monomers are combined together, that will produce a biocrude. So first stage, we do hydrolysis of biomass with solvent, then that will undergo degradation of the biomass materials, and then there will be a recombination mechanism, where this reactive monomers are going to combine, and which is going to produce the biocrude as a yield. So this is the schematic diagram of that entire HCl process. Start from the biomass and move on biomass together solvent will be added in the form of a slurry, and that will be fed into the HCl reactor, and directly if you supply temperature and pressure, so it may yield a gaseous products which contains carbon dioxide and methane. Or if you aim at producing liquid fuels, you have to go with the biocrude, which contains aqueous phase and other solid products. So there's an important step, or you can say that there is an important challenge in that STL process, that from the STL process, whatever the yield you get it, that's we call it as a biocrude. So this will be a mixture of aqueous phase and solid phase. So you need to undergo this separation process. Like generally, normally we all go with this gravity filtration, where we keep that biome, the aqueous phase, in a conical flask, and we leave it for 24 hours. And the solid particles, which is going to accumulate at the bottom due to the density factor, and that can be removed. And if you want that, you can further treat that solid particles, which is collected at the bottom of the conical flask, with the salt extraction process by adding some solvent, and you can separate the wet solid product and soluble fractions from that. You can from there also you can produce a biocrude, and the other part, that the solid residue which can be left over at the end, that can be considered as a char, which can be used as a fertilizer, or it can be further treated to produce activated carbons. And then from the liquid part, again, the aqueous phase, whatever you collected, again, this has to be subjected with liquid extraction. In that, again, you need to add a solvent, so like dimethyl ether, ethyl acetate, hexane, or toluene solvents. You have to add it, and that has to be a processed through this vacuum distillation process or rotary evaporation process. And from that, again, you can remove the solvent part separately, and you can collect the biocrude from that. So there is another method called centrifugation. So that also will separate the solid particles as well as the uh, biocrude fractions. So, and this is the process flow diagram, what generally HTL process will undergo. So this how this reactor looks like. It's a sample one. I will show the actual reactors in my following slides. So the HTL reactor is like a pyrolysis reactor. It's again stainless steel one with a lid at the top to seal the environment, and it is again heated by electrical means from the external way. And there is an option to measure the pressure, measure the temperature. You should connect the thermocouples to measure the temperature and pressure. And there is a stirring mechanism in the reactor, the motor at the top, that to give stirring action to enhance the HTL process. So this is going to deal with this solvent tank. So it is where you need to supply this biomass and solvent together. We have to make a slurry, and it has to be filled inside the reactor. Right? So this HCl reaction is going to yield aqueous and solid residues, and from that you can separate the solid particles like biochar and water soluble biocrude and water insoluble biocrude from that. And the HTL processing methods. So you can have different methods of HTL process. So direct simple process, direct HTL is simple process. Directly you can take any wet biomass, and you don't need to dry it, so it will reduce the cost, the capital cost of the HTL process. But it requires post processing. If you go with direct HTL process, whatever the yield you get it after the reaction, so that may undergo several steps of separation process for upgradation. And if you go with the catalytic HTL process, where you can use catalysts to improve the reaction rates, and that is going to increase the biocrude yield and reduce the oxygen content, which is going to be present in the biocrude substance. And there is another method called co-solvent to enhance the conversion efficiency, to reduce the char formation. That we can go with co-solvent HCl process. And the other method is the hydrogen assisted HCl. Normally for pyrolysis process or this HCl process, what generally we do, to start with the reaction, initially we purge nitrogen as an inert gas material, so which goes inside the reactor and replaces the entire air out of the reactor. So it has to, you have to ensure that there is perfect vacuum or inert environment which is present inside this one. So by passing this inert gas, we are going to replace the air outside. So like that, instead of purging nitrogen, you can also purge hydrogen also, that to produce high quality biocrude with lower oxygen content, but you need to supply external hydrogen than that. And there are some supercritical HCl reactors where the reaction rates are very high and gives very soluble biocrude fractions, but it requires higher energy input and pressure conditions. And then in recent days, there is a co-HCl process that is booming up where the biomass materials are mixed with waste plastics or any other recyclable materials or non-degradable materials together uh, to improve the biocrude yield and the quality of the value-added products. So this, anybody have seen this type of structure? How you name this one? How it looks like? How it looks like?
Boiler.
It looks like boiler. Any other? Anybody seen this autoclave reactors? Autoclaves. Autoclaves are also a kind of HCl reactors only. Like you can use autoclaves for HCl process. Right. So moving to this HCl reactor types. So you will find a batch reactor, which is going to be simple in design and which is going to be suitable for small scale or laboratory studies, but it has a limitation for the scalability. And again, there are some advanced continuous flow reactors for industrial scale production for large quantity of biocrude production. Generally, industries they go with this and continuous flow reactors. And there is a plug flow reactor also, which has high conversion efficiency, uniform flow, and easy to scale. But there is a problem with the plug flow reactor where it may undergo fouling effect. And again, the advanced versions will have the stirred tank reactor where there will be a stirring mechanism to maintain the uniform temperature and pressure distribution inside the reactor, which is going to be suitable for viscous feedstocks or heterogeneous feedstock, but it is energy intensive, meaning that you need to supply electrical energy to drive the motor to make the stirring action inside the reactor. And the fluidized bed reactors, again, sort of like the gasification we heard about this fluidized bed, circulated fluidized bed. So this will going to ensure this excellent mixing of biomass substance and enhance the heat transfer, which is going to be suitable for solid or semi-solid feedstocks, but the design is going to be complex and it requires heavy maintenance expenditure. And the coil tube reactors, they are going to be compact and efficient, but it's going to, and I'll say may that it is going to reduce the residence time variations, but there is a problem of clogging in the coil tube reactors when there is rich solid feedstocks are used. It will encounter this clogging problems. And the last one that I shown that in the earlier slide, maybe of autoclave reactor. So this is going to be suitable for high pressure handling capacity, and it is going to be suitable for studying reaction mechanism, but it is going to be inefficient for scaling up. So this again image which I have taken from my reference source. So this is a continuous stirred reactor combined with plug flow reactor. So where the biomass and water is going to make a slurry, and this slurry of biomass with water is going to be pumped inside the reactor. So first initial heater, and then it goes to the continuous stirred tank reactor with electrical heating. Then it is going to combine with the plug flow reactor. So this like a combined continuous stirred and plug flow reactors have advantages of both continuous mechanism as well as plug flow reactor mechanism. So that is going to yield a large quantity of biocrude, and the separation process is going to happen in all the cases. I'm going to the separation processes. the STL process separation methods. The first step is that phase separation. So first step, separate the biocrude, aqueous phase, and solid based on the density. That's the gravity separation I told. So it is going to separate the biocrude, aqueous phase, and solids based on its density and its solubility difference. Second step, it's filtration to remove the biochar from the liquid effluent using filters or membranes. And the third step that you can go with this centrifugation, that's going to be efficient for separating solid and liquid phases using centrifugal force. Or otherwise, we can go with the solvent extraction where biocrude can be refined by adding some solvent, and that was going to remove the impurities, and also you can get some other value added compound from that solvent extraction method. Distillation process is vacuum distillation process commonly used by food. So administration, you can separate the lower molecular fractions and heavy molecular fractions using the fractional distillation process. Here, what we call it as heavy oil fractions. And apart from this, byproducts are there from the STL process. So it is going to leave biochar, aqueous phase, and also biogas. So which has some value applications, and it can be refined into higher value added products. So biocrude is generally viscous in nature. It's again energy dense oil. Is used for transport. It can be used as a transportation fuel or heating fuel in furnaces, or it can be used as a chemical feedstocks, and it's going to be a carbon neutral fuel. And biochar, it's again a solid residue, carbon rich solid residue, which can be used for soil amendment, can be used as absorbent material, say activated carbons, I told now, activated carbons, or uh, promising materials used for carbon dioxide capturing process. For CO2 capturing, this activated carbons are used as absorbent materials, or it can be used as a solid fuel source. The aqueous phase, which is water rich fraction, which is again dissolved with organics and nutrients, it can be used for nutrient recovery, and it can be again further treated in anaerobic digestion process to produce a biogas, or it can be used to produce chemical feedstocks, aquaculture and agriculture one. And the final part, the biogas, is a gaseous byproduct which contains large amount of methane and carbon dioxide and other gases, which can be used as a renewable energy source like compressed natural gas, or it can be used as a energy resource for separating hydrogen from biomass resources, and it can be used for carbon capture and storage purpose. And the biocrude upgradation techniques, so it can be upgraded by hydroprocessing. Hydroprocessing generally process of removing the oxygen, sulfur, and nitrogen from the biocrude using this hydro-oxygenation or hydro-deoxygenation. So hydrogenation only by enriching the hydrogen with the biocrude, that will replace the oxygen content from the biocrude. And hydro-deoxygenation, again removal of oxygen from that biocrude product. And also that you can further upgrade the biocrude through catalytic cracking by breaking down the heavy biocrude molecules into lighter or hydrocarbons using some catalyst. Also, you can subject this biocrude with the transesterification process or esterification process. It's going to convert the free fatty acids into biocrude into esters. So what are the free fatty acids present in the biocrude that is going to convert into esters? That will reduce the acidity and that will improve the fuel properties. On the earlier stage that we discussed about the distillation process, again, you can separate the biocrude into lower molecular fractions and higher molecular fractions or heavier molecular fractions based on the boiling points can be separated and it can be used for further processing. This electrochemical upgrading that's going to employ electrochemical cells to remove the oxygen and nitrogen from biocrude. reduction mechanisms, and solvent deoxygenation uses solvents to remove the oxygenated carbons from the biocrude. What are the challenges? What challenges this STL process has, and the methods towards upgradation? Like the first one is the high energy requirements. So STL requires high energy so that it will increase the operating cost and it will reduce the efficiency one. And second one is the complex reactor design. So high pressure and temperature reactors generally are not easy, that you have to choose appropriate material, advanced materials to fabricate that reactors which can withstand high pressures and temperatures. So that will add the cost on the reactor design. And the biocrude oil quality. So again, the STL process, whatever the biocrude directly you get it from the STL process, is not, it cannot be used directly as a fuel directly. So it has to be upgraded to remove the unwanted impurities and to enrich the hydrogen content in that. And if you use catalysts, they are going to be expensive, and again, they are prone to deactivation and sensitive to impurities. So it has limitations. You cannot use catalysts also. They may not react when there are impurities present in the environment. So then the product separation, separating complex products mixes increases energy consumption and operational complexity, and scaling up is again a challenge. So translational from the lab scale to industrial scale steel process, it's going to process challenges like hydrogen reactor clogging and process control. And apart from that, there are some social and regulatory challenges. There is a lack of public awareness, and there is stringent regulations that can delay the steel adaptation and market penetration. So far, that is still not being made commercial in all the places. Only at that research level that people are doing. And the future prospects, if you discuss that, it can be proceed with the microwave irradiation. So that will increase the biocrude yield from lipid. That will produce comparable yields from protein and lignin and decrease the yield from the carbohydrate. And there is a lot of opportunities to adopt this machine learning techniques to predict the product yield and to predict the quality of the biocrude. You can predict with this machine learning algorithms, and rather than this using this conventional mathematical models. Right. So this is about the general one, and want to my experimental facility, what we designed it as an outcome of a sponsored research project funded by Department of Science and Technology. So this is a currently ongoing project where we have designed a steel reactor with this SS316 material with with withstanding pressure of maximum operating pressure of 250 bar and a temperature of 40 degree. It's a kind of autoclave reactor. It's a fixed bed reactor, one not a continuous one. And it is having a magnetic sensor with coupling, and there is a pressure relief valve to avoid any unwanted incidences during the reaction process. And it's 3 liter volume, but you can go ahead with the 2 liter volume, not that full volume. You can use it for the STL process. And there is option for nitrogen purging, and we have external cooling coil arrangements we provided to reduce the temperature of the reactor once the reaction is getting over. So this was designed by a supplier from Mumbai, so Nanomech Technologies, and this is the design input that we have provided to the vendor. So you can find this reactor with the motor, electrical motor for this stirring mechanism, and there is a provision for nitrogen purging, and all other components or mentioned over there. And there is a temperature controller in it. You can adjust the temperature and pressure with this controller in it. And here there is a cooling water circulation tank, and from that separate pump is there to supply the coolant to cool the environment, the surroundings of the reactor. And this is the actual photograph of the setup that we fabricated from that particular project. So you can see that whatever the design we provided based on that, fabricated and they provided it's of 3 liter capacity, and we started doing experiments with this particular facility. So this is how the reactor looks like, and the stirrer is put in that, and where we keep the biomass slurry, and there is a stirring mechanism to make the slurry ready. And these are some solvents we use during the reaction process. And for our purpose, for STL process, we have selected 3 different algae biomass materials. So one is that spirulina, chlorella vulgaris, and sargassum. What we call as seaweed. And also we tried with this rices, wheat husk, and some forest waste material like sawdust, which is obtained from this juliflora wood. So we have done this complete characterization, that proximate analysis, ultimate analysis, and FTR analysis for finding out the elemental composition present in each biomass materials, like carbon, nitrogen, and we found out the high rating value, and we measured the, we had done the ultimate analysis to find out the volatile substance present in the biomass. So these are the results that we obtained from this ultimate analysis. So the 5 different species what we selected for our reactions: first spirulina species and sargassum species, and rices, wheat husk, and sawdust. The carbon composition, hydrogen composition, oxygen content, nitrogen content, sulfur content, and that calorific value. So out of all this 5 biomass, the first one, that algae biomass, chlorella workers, which is of spirulina species, so that contains the maximum amount of high rating value of 16.16 megajoules per kg, and that we have considered for further conditions. So these are our operating conditions. We set the temperature between 250 to 350 degrees, and we vary the temperature at different intervals, 250 to 75, like that. For different temperatures we tried, and pressure we started from 70 bar to 150 bar, and we provided the resistance time of 15 to 45 minutes based on the feedstock concentration. And the uh, feedstock concentration what we have chosen is 1:3 and 1:10, that we have used. One is 1 part of biomass and 3 parts of solvent. At the stirring speed we maintained at 300, 600 RPM. And this is the experimental conditions what we provide. We maintained temperature at 300 degrees Celsius and the resistance time of 30 minutes, and 1:10, that feedstock ratio that we maintained it, and the autogenous pressure that will automatically maintain at 70 to 100 bar, and a stirring speed of 300 RPM. Further, that after the reaction mechanism, that we undergone this gravity separation process, vacuum separation process, filter paper separation process, and simple distillation process to separate the biocrude into that lower fractions and heavier fractions. And these are some photographs. So for gravity separation, simple distillation of this biocrude, and then we've gone for this bio crude oil, whatever we collected from the HTL process, that we treated with the, again, elemental analysis part. We find out the carbon, nitrogen, sulfur content. We tested our sample with GCMS analysis to find out the chemical composition and to find out the functional groups. It is subjected with FTR analysis, and the thermal properties, fuel properties, like calorific value, viscosity, density, flash point, on cloud flow, the cold flow properties like cloud point and pour point also we measured. So these are some images that we collected from our actual experiments. The biochar, the biocrude obtained from this spirulina algae, and the aqueous phase after separation we collected, and this is sawdust, and from that whatever the biochar we collected. And we have the results of yield percentage of different biomass materials at different operating conditions, and the different operating temperatures. Let's say from 260 degree, 280 degree, 300. For every 20 degrees, we conducted the experiment by maintaining the residence time of 15 minutes and 30 minutes. We found that the carbon, nitrogen, sulfur, oxygen content, and we check the calorific value where we get higher amount of calorific value. So based on that, we have chosen the bio oil for further engine experiments. So these are again the properties of different biomass materials. This again biomass sample analysis before the oil, that what are the biomass we used for our investigation. We we tested the proximate analysis and ultimate analysis to find out the elemental analysis components of composition of their biomass material. And this again the FTR analysis of the biomass materials, and you can see that the what are the functional groups present in the biocrude substance. You can find that it contains alcohols and ethers, aliphatic ethers, right? And alkenes, all are there in the biocrude that we collected from this wheat and sawdust material. Same as that, we are done testing for algae biomass samples also. And we have tested the biocrude with making blends the diesel, and we tested that in the single cylinder air cooled diesel engine. It's of a variable compression ratio engine with a maximum power of 4.4 kilowatt, and this is how the test engine facility that looks like it's they are available in our campus. So we have a variable compression ratio engine with eddy current dynamometer, and we have this exhaust gas analyzer to measure the exhaust emissions, and this diesel smoke meter to measure the smoke opacity. So before testing that, we need to know the fuel properties. We measure the viscosity, surface tension, density, calorific value, CT number. It's like a cumulative CT index, and acidity value, flash point, fire point from a standard test facility. And we measure the performance parameters like brake power, brake thermal efficiency, brake specific fuel consumption, exhaust gas temperature, and the emissions like CO, HC, NOx, and smoke emissions. And if I'll stop you for a while, if any questions are there from the audience, I'm happy to answer it. Or shall I complete my presentation and I'll wait for the questions?
Sir, kindly proceed with presentation, sir. At the end of the session, we will ask the participants.
Fine. Thank you, Dr. Abhishek. So this is the variation of brake thermal efficiency at different brake power conditions for the tested blends of that optimize the blend whatever we collected from that STL process. We made blends of 10% and 20%, and with both the case that it gives maximum thermal efficiency of 32% and 31%. When it is compared with the diesel fuel, it's going to be slightly lower due to the lower calorific value of the bio oil blends. So the thermal efficiency is going to be less as a result of that. And in the engine performance, what we found that maybe due to this larger droplets, like due to high viscosity nature, it may form high droplet formation and during automation, and it may not mix thoroughly with the air, and because of that, it may lead with the lower brake thermal efficiency in the case. And brake specific fuel consumption, generally it is again measure of the calorific value. So if the fuel has higher calorific value, you may come up with that lower brake specific fuel consumption, since these fuels are having lower heat content, so and higher viscosity, so the brake specific fuel consumptions are slightly higher than the diesel, but it is closer to diesel fuel in the case of 10% blend. And the exhaust gas temperature, generally it is going to increase with the brake power in diesel engines, and for the different fuels, the exhaust gas temperature and BP trends are shown that in this image. And normally the biomass-based fuels like bio oils or the STL bio crude oils, by default, whatever the way that you treat it with the separation process, it may have some moisture content inbuilt. So that may have a cooling effect. So because of that, it may come up with lower amount of exhaust gas temperature compared to diesel fuel in the exhaust. One of the emissions part, so all we know that the all biomass based fuels, biodiesel or biocrude or bio oil fuels will have oxygen content, where the diesel fuel won't have oxygen substance that in the molecules in the fuel. So this will lead to lower amount of carbon monoxide emissions, and generally CO emissions are caused due to the oxygen scarcity. If there is proper oxygen availability is there, you won't get more amount of carbon monoxide emissions. And if there is inadequate mixture preparation and incomplete combustion, that may lead to higher amount of CO emissions. But here, CO emissions are decreased in the blends due to the oxygen content present in the bio oil. And same way that the HC emissions also, as a result of that, more complete combustion, enhanced combustion efficiencies, this also emits with lower amount of unburned hydrocarbon emissions. And the NOx emissions, if you say that, it's again a function of combustion temperature and the oxygen environment. The NOx gets formed when there is a high combustion temperature and oxygen is available at the combustion chamber. Right, so this NOx emissions will increase when the combustion temperature gets increased more than 1200 degrees Celsius. And here, when you compare the NOx emissions of diesel fuel with the algae bio oil blends, so that exhibits lower amount of NOx emissions due to the presence of water and other ethanol. Ethanol just to be used ethanol as a solvent. So whatever the way that we use separation process, by default there will be some alcoholic substance and water combined with the biocrude. So that is going to have a quenching effect on the combustion chamber temperature. So that's going to reduce the NOx emissions part. And smoke emissions are again slightly higher smoke capacity. So the slightly higher smoke opacity was exhibited with the bio oil blends, and due to this increased viscosity and reduced atomization constraints, that it does the complete combustion of this one. Right. So coming to the conclusion part, what of the STL experiments we successfully conducted under the optimized conditions at a temperature of 300 degree and a residence of temperature time of 30 minutes with the feedstock ratio of 1:10 at a steering speed of 300 rpm. The pressure we maintain the pressure at 70 to 100 bar. So this yielded a promising bio oil yield. So we tried with the different temperature and residence time conditions, and this was the optimum condition that we obtained from that experiments. And in terms of performance parameters, so these blends of biocrude demonstrated a reduced engine performance with lower brake thermal efficiency, higher brake specific fuel consumption due to lower heating value and higher viscosity. And emission wise, that it exhibits lower HCCO and NOx as well as smoke emissions. So these are some references that we used for the presentation, and thank you very much for your patient listening. And if I'm happy to answer your queries.
Thank you, Prakash,
thank you
sir.
very much.
Wonderful
Thank you very much.
presentation.
Thank you very much.
Now session is open for question answer. Mr. Kiran. Mr. Kiran.
Hello, by mistake I have raised the hand.
Okay. Mr. Swapnil. Those who wants to ask some questions, kindly raise your hand.
and one by one ask the question. Mr. Swapnil? Mr. Swapnil? Anu Sharma? Anu Sharma? Dr. Amar?
Good evening,
Dr.
sir.
Amar? Yes.
Yes, sir.
Do you want
Good
to ask
evening,
any
sir.
question?
Yes, sir.
Yes, sir. Please, sir.
Good evening, Prakash, sir.
Yeah, good evening, professor, please.
Sir, my question is related to this. Everybody is telling that EV will replace all these ICs, and we are talking about this biofuel and all these green fuels and all. So, coming to that context, sir. So, what we are expecting after the next 10 years, whether the biofuel itself, what is area reserved, or it will be completely replaced by the EVs, sir.
Okay, very good question. Okay. You cannot avoid completely the internal combustion engines. So, for example, if you take the commercial transport of goods, so you cannot fulfill that with the EV market. So even the manufacturers of the EV electric vehicles, they agreed that where they will go for this large storage capacity of batteries, and from which source that we make that batteries for to fulfill the complete fleet of transport sector. So it will be quite impossible to, to completely avoid the commercial vehicles like with the automotive engines at the sake. This is my opinion.
Thank you, sir. Dr.
Sir.
Sridhar, Dr. Sridharala channel.
Yeah. I'm Dr. Sridharala Ramu.
Yes, sir.
Yes, professor,
Sir,
please.
yes, your question is, sir, as you know that in 2000.
Sir, would you like to ask some question? Yes, sir.
Yeah, I'm asking question.
Yes, asking.
Hello.
Yes.
Hello.
Yes, sir. Yes,
Can you
sir. Yes,
listen
sir.
my
Please,
voice?
sir. Yes, sir.
Please,
Audible, sir.
go ahead, go ahead.
I'm Ramu speaking. Can you listen my voice?
Yes, sir. Yes,
Yes,
sir. Audible,
professor,
sir. Please proceed, sir.
Sir, in 2003, there was a lot of research took place for the biodiesel and biodiesel production, and some trials were also conducted for the biodiesel. But why the biodiesel is failed in India?
No,
Why
like
not
I
in
don't know
India?
how many of you know that the whatever the gasoline that you are getting in the fuel stations now. So this is E20 only. It is available now. So if you go to petrol pump, whatever the gasoline fuel that we are pouring into our vehicle, that's again E20. It's not a complete 100% gasoline. Already India started implementing this biofuel policies, and first they started introducing ethanol blended gasoline in fuel stations. First, in the last 2 years back, 5% adulterated ethanol was available. And exactly, if you know now, the current situation is that the E20 gasoline is only available at the fuel stations. And even with the diesel also, very soon that the 20% blend will be implemented for commercial vehicles. It's again, it depends on the customers like us that whether are we going to use that B20 blend or not. Still, many engine manufacturers are not completely turned towards that adapting the adaptation of that engines to the alternative fuels. So those older engines are still struggling with that E20 fuel. Even I have personally experienced this with my friend's vehicle. So the GDI engines are struggling with that. The not GDI engines, but MPFI vehicles are struggling with that E20 fuel. Oh, but the government has taken initiatives that we cannot deny on that.
No, hello, sir.
Yeah, please. Yes, please.
Actually, my question is, why biodiesel is failed in India?
No, that we cannot say that it's failure. No? It is like it's in the stage of implementation only. already people they started implementing biofuels in blending stage. So they started blending of biofuels like ethanol in gasoline. Same as that, the biodiesel fuels blends can be blended with diesel fuel, and that is going to be sold in the. On what way that you are saying
Bhairav
that it's.
Vaibhav?
Hello. Hello.
Yeah,
Good
yeah,
evening,
please,
sir.
please.
Sir, my question is that the HTL, there is main drawback of the HTL with the clogging and the corrosion problem. So, is there any way that we avoid these kind of situations so that the efficiency of the HTL would be higher?
Maybe we can go ahead with that continuous reactor with some advanced arrangements with the coil. If we adopt proper cooling systems, and again the biomass quality, what biomass we make with the slurries, the particle size of the biomass also an important parameter there.
Okay.
But still, it's a challenge only. So we have to come up with different solutions. We are at the experimental level only. So we also experienced with clogging of our reactor outlets.
Yeah, the
And
main problem is the clogging and the corrosion problem is the main problem.
Exactly.
Yeah.
Corrosion problem we cannot avoid again if you use some solvents like water or some other materials. So it should be actually we should use neutralized water like distilled water for that reaction purpose.
Okay. Okay, sir. Thank you, sir.
Vishal Kalia.
Sir, one question is in chat box from
Hello, sir.
Sujit Kumbhakar.
Yes,
Which
sir.
change
One question,
should
sir.
be made when bioethanol is blended with petrol?
Biodiesel means that biodiesel is applicable for diesel engines, not for gasoline engines. So both are different purpose. You can't mix diesel and petrol together. Gasoline can be blended with alcohol like substances or high volatile substances. They are some lower molecular fractions. So those kind of substances only can be blended with gasoline.
Ravi Ranjan.
Yes, sir. One question, sir.
Yes.
Yes. What is the main problem of using biofuel as a source of renewable energy, sir?
Please, your question, please.
What is the main problem of using biofuel as a source of renewable energy?
What is the problem you are asking?
Hello.
The problem in biofuels, all biofuels is that
तुम नौ ब्राह्मण पारस थे।
the stability.
मैं ना आपको
Any
एक
kind of biofuel will be stored for a long time, say 1 month or one time. It should be stable in nature. Abhishek? Dr. Abhishek? My
Yes, sir.
was gone.
By mistake.
Sorry. Okay, thank you. Thank you very much.
Okay, sir.
The program completed, sir.
Any question from participant side?
Okay.
Side.
Dr. Sri Lal. Some people has raised hand. Ravi Rajan.
Yes, sir. Ravi Ranjan, sir.
Ravi Ranjan. Yeah. Any
Yes,
question?
sir. What is the main problem of using biofuel as a source of renewable energy?
No, like the problem is that like you need to upgrade the biocrude. You cannot directly use the biocrude as a fuel. So whatever the biocrude you get it should be upgraded. It should be first separated with the aqueous phase and other impurities, and you can upgrade the quality by doing hydrogenation or some other way that you have to improve the stability of the biocrude oil, and then you can go for engine performance part. Otherwise, that there is no issue with that.
Sir, biofuel, including land and water resource requirement, air and groundwater pollution, sir?
No, biocrude actually we produce biocrude from the algae biomass, like it's aquatic plants available in all plants and lakes. So it can be cultivated in a laboratory environment also. That the raw material is this one only. But you're talking about the biocrude. So it's again a biodegradable only, na? So it's only biomass based. It is completely biodegradable. If you live in that atmosphere or land also, it will degrade. It won't have any negative impact on the environment.
Okay, sir. Thank you.
Sunil Kumar Singh. Is any query from your side? Sunil Kumar Singh. Bhairav Vaibhav. And
Prakash sir.
Yes, bro.
Hello.
Yes,
Sir,
doctor.
one question from my side.
Yes, please.
In most of the cases, sir, it was said that EV are no emission or zero emission vehicle like that. But what I believe, sir, for charging the EV, we need electricity. So in
Exactly.
that case, from thermal power plants, we are using coal and etc.
We
So
cannot avoid completely the hydrocarbon fuels.
yes, sir.
Anyway, that the majority of the power production is still made from the thermal power plants only.
Yes, sir. And even, sir, in some case studies, I have read that CO2 emission from EV for EV charging are more than for compared to any diesel engine or a petrol engine.
Correct. So that for that much amount of electricity charging, that what are the energy produced? What is the source of energy electricity generation?
Yes, sir.
Correct. Well said.
Yes. Any more question from participant side? Participant side?
Yes, sir. Myself, Dr. Mukund Kumar.
Yes, please.
Sir, this is not my question. This is one of my suggestions. I want suggestion from Prakash, sir.
Yeah, please,
Sir, during the experiment, we just change the fuel injection pressure, fuel injection timing, load, compression ratio. So
Yes.
apart from this, can you suggest me some of the input parameters which we can vary?
Those are all conventional way of optimizing the engine variables. But now, if you start trying with the engines with advanced configurations like CRDI engines are there directly. Even for a single cylinder engine also, that CRDI facility has come. that open ECU has come. So no need to touch those parts in the conventional way. You can electronically vary the injection duration, injection timing, these things, and even with the CRDI system that you can go with very high pressures of up to 800 bar. And now whatever the way you attempt, so anyway that there will be some emissions, HCCO and work smoke that you will interpret. Now modern trend is towards achieving the low temperature combustion. So
Definitely, sir.
think of trying with the low compression temperature strategies like premixed charge compression ignition or homogeneous charge compression ignition, even that RCCI one reactivity controlled compression ignitions. So those can be tried for any kind of biofuels.
Yes, sir. Sir, I've already worked with the RCCI, low temperature combustion, sir, and I already had the pressure up to
Fine,
501.
We use two different reactivity fuels and to try with that.
Yes, sir.
Fine, very good. And there is no other options like either you can optimize the fuel parameters or you can optimize the engine parameters. That's all. There we come to end. Now shift is towards adopting machine learning approaches.
Definitely.
That way that you can try. That will reduce your number of experiments.
Okay. Thank you so much, sir.
Hello.
Yes, Professor, please.
Hello, I'm Sridhar Alramo.
Yes,
Sir,
Professor.
sir, one direct question is lithium-ion batteries are environment friendly, according to you?
No battery is not friendly, user friendly, but it's fully biodegradable. Then you can say that lithium-ion batteries again not a biodegradable, fully eco-friendly one.
But
If you dispose that, maybe we come to face that issue after 5 years. Now only that EV trend has boomed, right? Maybe all of move towards EV, and now we can see many vehicles running on the road with EV. But once the first cycle is completed, or we have to wait for 2 more cycles. So the battery lifetime they give warranty only for 5 years. After 5 years of period, what they are going to do with the battery, where they will throw or how they will recycle it. So that's going to be a challenge again.
No. One problem I went through by articles. Lithium-ion batteries, they are only environment friendly because they don't emit any air pollution. But the mining of lithium and cobalt and graphite, that cause enormous of pollution, air pollution and water pollution. And how to dispose of this lithium-ion batteries is also a big environmental threat.
That will be a challenging issue only. Like we will face those issues in coming days again.
So we cannot say now. Now we cannot give.
We cannot say for some solution for that. So you have to
Yeah.
wait, watch.
Right. Exactly. Right.
Thank you, Professor.
Any more question from participant side?
Hello, sir.
Vaibhav Bhairav?
Hello.
Yes.
Hello, sir. My question will be according to the transportation of the biodiesel fuel. At the time of the transportation, diesel and petrol get transport one station to the another stations. At the time, due to the density, more of fuel get directly flow to the environment. Okay, at the as based to the air. Such types of the problem will be create in our biodiesel transportation system.
What generally people suggest is that you should not not to suggest to transport the fuel. So generally it should be consumed at this spot. Like for industrial applications or for large scale applications, you produce biofuels and burn it in a furnace, complete your process done. If you want to transport it, again you have to think of the fuel properties about the flash point, fire point. But generally, this is safe to transport. There is no issue with the biofuels. And as long as that the flash point is higher than diesel fuel, generally all biodiesel fuels will have more than 100-degree flash point, and that is safe to transport. Only thing in case of a spillage, your question is that in case of a spillage, what will happen to the environment, right?
Nice. No, my question will be the at the time of transportation, diesel or petrol is going to the airs as due to the density and wastage of the fuel as like a vacuum. Okay, at such type due to the density, that type of the losses is generated in our diesel and petrol. Generally, we have to the looking at the time of the filling the tank, filling
Oh,
the
like
petrol
you are
in our
talking about this,
motorcycle.
the operation losses. You are talking about
Ah,
the operation
such
losses.
such types of the losses can be
But this,
generated in the
this biodiesel fuels are not that much volatile like your gasoline or diesel fuel. So it won't have that much operation losses.
what about the according to the density, which types of the fuel having the low density? Biodiesel having what types?
All biodiesel fuels will be slightly higher denser than diesel fuel. You won't get a lesser biofuels.
Diesel or petrol, both of them
Oh,
higher
yeah,
density.
it will be of higher density only.
Okay, or most of the biodiesel can be produced with the help of the plant,
Yes,
such like a sugar cane or any other.
any biomass resources which is not used as a food material. We should not suggest vegetable oils for
A-
biofuel production.
in our sugar factory, more of them going to the ethanol producing.
Yeah,
Okay,
yes.
that ethanol directly used as a manufacturing as a biodiesel.
Yeah, you can use ethanol as a byproduct, not byproduct. It's a reagents for biodiesel production. So ethanol is again alcohol fuel, not a biodiesel. You cannot call that as a biodiesel one.
But it can be used to the
And
as a raw material.
you can use as a raw material for biodiesel production.
Biodiesel production.
Yes.
Okay, and ethanol, how much time required to the ethanol convert to the our biodiesel? Any types of the such analysis or any types of the change?
There are a lot of research papers available that how much time it will take for that biodiesel transesterification process.
Or any types of the analysis as required to the farmer growing such types of the plants have required produce the maximum biodiesel. We have to the getting the some analysis about that farmer side.
No, I'm not getting your question exactly. Like you are asking for
My
some.
question will be some plant such like a sugar cane having produced the
Correct.
ethanol.
You can,
Ethanol.
yeah, you can from the molasses that you can convert that into alcohol production, ethanol production. This alcohol, ethanol, you can use it as
Basically, in SI engines, ethanol blended with petrol is being used. Vijay, let me
Yes, sir.
answer
Yes,
your
sir.
query.
I know that
Huh?
about. But
Huh.
my question will be the ethanol is directly converted into biodiesel or some
No,
other
no, ethanol is not directly converted into biodiesel. It is just as sir told you, it is basically used as a part of reaction. If we want to convert using transesterification any vegetable oil into biodiesel.
Okay, 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 okay.
है ना?
Okay.
Ethanol
Thank you,
is
sir.
dedicatedly used for SI engine, used in SI engines worldwide. Say
Only.
country like Brazil, US, Europe, many countries in Europe, they are using ethanol blended with petrol or using ethanol, separate dedicated ethanol vehicle also, flex fuel vehicle, these are known as FFV.
Okay, okay, okay,
Right?
sir.
Okay. Yeah.
Okay, sir. Thank you, sir. Thank you.
Sir, can I answer for this biodiesel production? That actually in the biodiesel production, methanol is a best choice than ethanol. As you said, ethanol is not one. Methanol is the best choice. Why? Because it's a high polar. So biodiesel production, you are taking vegetable oil like chatropa oil, particularly chatropa oil, and you are adding 3 moles, and the process is called transesterification, and that which produce biodiesel and glycerol, which is a byproduct of this biodiesel production. So this is a general procedure, or a commercial procedure to get the biodiesel.
Okay. Oh, thank you, sir. Thank you.
Prakash sir. Prakash sir, are you in meeting?
Sir, I think Prakash sir is out.
Okay, okay. So thank you very much, Dr. Prakash sir, for your valuable insights regarding biofuel and its environmental impact. We can take break for 10 minutes, and second session will be started at 8 p.m. after 10 minutes. Second session will be taken by Mr. Prabodh Ranjan Padi, former Chief General Manager from Rourkela Steel Plant. So we are ending the meeting for 10 minutes, and by the same link, all the participants can join the second session. Any doubt from participant side? And many participants are asking about the attendance. So let me tell that attendance is already recorded during Google Meet. Once we will close the meeting, we will get the Excel sheet by the Google Meet itself. So whenever you are joining, whenever you are leaving the meetings, everything will be recorded, and duration, all the information will be recorded in that Excel sheet. So need not to worry about the attendance and feedback. Feedback will be asked at the end of the FDP. Thank you very much. So we will join for second session at 8 p.m.
Thank you, Dr. Abhishek.
Thank you,
For
sir.
giving me the opportunity.
Prakash sir,
Thank
sir,
you, thank you.
really, I am very much thankful
Thank
from
you, sir.
bottom of my heart, sir, for valuable presentation. Thank you very much, sir.
Thank you very much. Sir.
Thank you, sir. Thank you, sir.
Thank you all participants. Sir. Have a good day.
So we will
Thank
start
you.
second
Thank you,
session
sir.
at 8 p.m.
Thank you, sir. Thank you
Thank
very
you,
much.
sir.
Thank you.
Thank you.
Thank you, Dr. Abhishek. I'm leaving.
Yes, yes, sir. Yes, sir. Dr. Murli,
Yes, sir. Yes, sir.
please stop the recording and then end the meeting. And we will start the second session after 10 minutes.